So today we are going to see timer 1 till timer 14. These many timers are there in this controller, right? And some of them are 16-bit timers, some of them are 32-bit timers. So here in this particular controller you can see that timer 2 and timer 5. These two alone are 32-bit timers, all the others are 16-bit timers, right? And the count type is also shown here. So for timer 1 and 8, it can perform up counting, down counting and up down counting. Up down counting is generally used for PWM generation. Similarly for timer 2 and timer 5 also, up counting, down counting and up down counting is possible. But you can see in these timers only up counting is possible. You cannot perform down or up down counting, right? And these are the prescaler factors. What do you mean by prescalers? We will see later. So now for time being, understand that all these timers we can have prescalers from 1 to 65536. 65536, it is equivalent to 32 ones, 65536, right? 0 till 65536 we can have, 1 till 65536 we can have. Then these are the number of capture compare channels for each of the timers. So capture and compare, I think last class I have told, capture mode of operation of timer, you can consider it something similar to stopwatch. Compare mode of operation you can consider similar to alarm clock. So these many channels are available in each of the timers. So what do you mean by channel? In timer 1, 4 capture or compare channels are there. That means if you are performing say capture operation, what should you give? Whenever you are giving an input, you will start the timer, and when you are giving an external input, capture operation will take place. Current value of counter will be captured and stored onto capture compare or capture registers. Right. So here in this case 4 input channels are there. What does it mean? You can give inputs to 4 external pins. So up to 4 external inputs you can give as capture or compare inputs to say timer 1 and timer 8. Similarly for timer 10 and 11 only one capture or compare channel is there. So in the case of capture channel you can give input to a particular pin. In the case of compare channel, what do you mean by compare? When a particular time is reached, it is equal to alarm clock. When a particular time is reached, alarm should be set. Here alarm can also be an external event. That means an external event will be generated on a pin. But in capture you are taking an external input. When the timer is getting external input, capture operation will take place. In capture that pin should be input, but in compare that particular pin should be output, right? So these are the number of capture or compare channels available corresponding to each of these timers. So for time being, for this class we will be dealing with timer 2, which is a 32-bit timer. So before going into a timer, we need to have a small idea regarding STM32 clock. What are the types of clocks available? So in STM32, this particular controller 446, 3 different clock sources are there, which can drive the system clock. Which are the 3 different clock sources? They are known as HSI, HSC and 2 PLLs. HSI stands for high speed internal clock. So for the system tick timer also, we were using this high speed internal clock as the clock source for system clock. And by default, it will be 16 MHz. Then we can connect high speed external crystal oscillator also as a clock source, and system clock can take the input from this clock source. So here you need to give an external oscillator, external crystal oscillator. So always HSC will be more precise than HSI, right? Because always the external crystal oscillator will generate more precise clock than HSI. But what is the problem in HSC? You need to have an external component attached to the controller. But if you are configuring, if you are using HSI as a clock source, since it is high speed internal oscillator, you don't need to connect an external oscillator. It will be generated internally. That is the advantage. But coming to accuracy, HSC is more accurate. For time being, you are using HSI. Then in addition to these two clock sources, two main PLL clocks are also used as a clock source for system clock. What are the two main PLLs? One is low speed internal PLL and low speed external crystal PLL, which is connected to this one. So two PLLs are there, right? PLL, what is the function of PLL? We can configure the border, we can configure the clock, right? Phase locked loop, it is used for configuring the clock. That means you can divide the clock. If you are setting PLL to say 1, what does it mean? Whatever clock you are generating, that will be divided by 1. If you are setting PLL to say 4, whatever clock you are generating, it will be divided by 4, like that. So these are the three main clock sources. In addition to these three main clock sources, there are two secondary clock sources are also available. Two secondary clock sources. These two clock sources are basically used for real-time clock peripheral in the controller, which is keeping track of time. Right. In most of the devices, say in smart TV, when you are starting itself, it will show the current time. Who is keeping track of that? There is a particular RTC inside that, if it is not connected to Wi-Fi. Right. If you are having a standalone device without the Wi-Fi and other things for syncing the actual time, what will be there? Inside this controller, there is a particular peripheral known as RTC, real-time clock. If you are configuring this, you can configure the actual time of the controller. And based on the time, certain action you can perform. Say a device controller, when a device should be on at a particular time. Where will you configure that time? In RTC. So the two secondary clock sources are generally used for RTC. What are the two secondary clock sources? They are low speed internal RC clock or low speed external crystal clock. So the low speed internal RC will be of frequency 32 kilohertz. It is specified as LSI. Right. So it is generally used for RTC or watchdog. Watchdog means it is used as a timer which is used for protection. More details we will see later. Right. Similarly, there is a low speed external clock source also available. So here also you need to connect an external crystal oscillator, and that crystal oscillator will be always 32.768 kilohertz. When you are going through the RTC peripheral, you can see that for all the controllers for the RTC operation, if you are using an external crystal, that crystal will be of frequency 32.768. So if you want to run the RTC using low speed external crystal, you will be using the crystal of this frequency. So this is known as, this source is known as LSE, low speed external crystal. And LSI stands for low speed internal RC. So these are the two secondary clock sources. So this is a small block diagram representing the clock tree of 446. Right. So here you can see 16 megahertz HSI clock source is there. Right. This is that line. This is that line. Right. And this is a multiplexer used for selecting any one of these 4 clock sources, or specifically 3 clock source. That is, one is HSC, HSI and PLL. Right. HSC, HSI and PLL. Right. So this is a multiplexer selecting any one of the clock source to the as an input to the system clock. So for time being, if you are selecting HSI as the input, what will happen? 16 megahertz HSI will be connected to the system clock. Then yesterday we have seen system tick timer, right? So from where does the system tick timer get the clock? System tick timer can have clock selected or getting from system clock or from external clock, right? So system tick timer can take the clock from system clock directly or from an external clock. External clock is nothing but the system clock divided by 8, right? System clock divided by 8, or Ahb prescaler also will be there. So Ahb prescaler by 8, right? Ahb prescaler by 8. So if you are configuring system clock with external clock, the Ahb prescaler by 8 will be taken, otherwise system clock will be taken. Right. So this is known as a system clock. From the system clock, again it is getting converted to Ahb and APB. When we have taken LPC 2148, I have told that the same Ahb and APB. Ahb stands for what? Advanced High Performance Bus. APB stands for Advanced Peripheral Bus. Right? So there are few peripherals, or you can call it a system peripherals, which should be operating on higher speed, that will be connected to AHB bus, Advanced High Performance Bus. Right? So which are those peripherals or components connected to AHB? You can see here. One is the CPU, right? AHB is providing clock to the CPU. Another one is pre-running clock of the cortex, is the CPU clock. Then there is another pre-running clock which is used for several peripherals. That is a pre-running clock that also is connected to AHB. Then there are some system peripherals which is also taking or connected to AHB. Right. Some of the debugging peripherals we have seen in the some of the classes. So those peripherals are also connected to AHB. Right. So system clock is connected to AHB, and the other peripherals are connected to AHB. So here there is one prescaler which is associated with AHB, that is known as AHB prescaler. What do you mean by prescaler? It is used for dividing the clock, right? If I am telling that my prescaler ratio is 1:1, what does it mean? Whatever clock you are connecting here, or whatever clock you are giving here, if the prescaler ratio is 1:1, when it is getting an input, one clock is received here, it will generate one clock at the input. Similarly, if the prescaler ratio is 1:2, what does it mean? When two clocks are given at the input, only one clock will be generated at the output. If it is 1:4, what does it mean? If it is getting 4 clocks at the input, then only one clock will be generated at the output. That means you are dividing the clock by these factors. So AHB prescalers can have values from 1 to 512. Right? And the maximum frequency the AHB bus can generate is 180 megahertz. That is known as a AHB prescaler. Then from the AHB, it is connected to another prescaler known as APB prescaler. Right? Because from the AHB bus, APB bus is connected. So by configuring the APB prescaler, you can configure the clock which is connected to APB peripherals. So here you can see that again 2 APBs are there in 476. One is known as APB1, APB2. So APB2 is operating on higher speed when compared to APB1. Right? So the fastest bus is AHB, that is operating on 180 megahertz. Next faster bus is APB2. It can operate maximum 90 megahertz. And the lowest speed bus is APB1 bus, which is operating on maximum 45 megahertz. So there are certain peripherals connected to APB1 there are another set of peripherals connected to APB2. So which are those peripherals connected to these corresponding APB1 and APB2? You need to go through the corresponding data sheet for finding out the actual peripherals, right? So by configuring the APB1 prescaler, you are configuring the APB bus clock. So again, as I have told for Ahb prescaler, APB prescaler is also dividing the clock. So APB1 and APB2 prescalars divide the clock which is generated from the Ahb prescaler by these values. So if it is 1:1, what does it mean? When you are giving one clock at the input of APB1 prescaler, it will get one clock. It will generate one clock. If it is 1:2, when you are giving two clocks, it will generate one clock, like that. Right? So here, one more thing you need to keep in mind here. Even though your APB1 and APB2 prescalars can be configured from 1 to 16, for the timers, you can see that certain set of timers are connected to APB1, another set of timers are connected to APB2. So whenever you are configuring the timers, you can't have these many prescalars. You can have only two prescalars. If APB1 prescaler is configured as 1, then the prescaler ratio will be 1:1. Or for other, all the combinations, that is 2, 4, 8 or 16, whatever value of prescaler you are configuring here, you will be getting only prescaler ratio 1:2. That means if you are giving 2 clock at the input, you will get 1 clock at the output. 2 clock at the input, 1 clock at the output. Right. But for all other APB peripherals, you can have the prescaler configured as 1:1, 1:2, 4, 8 or 16. But for timers alone, you are having only two prescaler configurations possible. That is 1:1 or 1:2. That you need to keep in mind. So for all the timers, you can have only two APB1 prescalars or two APB2 prescalars. If you are configuring here 1, you will be getting 1:1 prescaler. If you are configuring with any of this value 2, 4, 8 or 16, you will be getting only 2 prescalars or 2 prescaler ratio, that is 1:2 prescaler ratio. So this is the clock tree. Other things now we don't need to discuss. So this is the address mapping of STM32, right? So you can see that each of the devices are having corresponding address ranges. Why? Because for configuring each of the peripheral, you are having a set of registers that is to be configured. Each register is having corresponding address. So for example, if you want to configure USART2, we need to configure certain set of registers. Those registers are mapped onto this address location, starting from 440 to 47FF, like that. Right? So this is the range. These are the peripherals and corresponding addresses mapped onto APB1. So similarly, there are certain set of addresses mapped onto AHB bus, APB2 bus, and this is a figure showing the address and peripherals mapped onto APB1. So you can see that timer 2, timer 3, 4, 5, 6, 7, 12, 13 and 14. These many timers are mapped onto APB1. These timers are connected to APB1. But timer 1, timer 8, etc. are mapped onto APB2. Right? So timer 1, timer 2, etc. are mapped onto APB2. But timer 2, 3, 4, 5, these timers are mapped onto APB1. So here we are concentrating on timer 2. So I need to perform all the configuration as well as prescaler configuration related to APB1. You don't need to configure APB2. This thing you need to keep in mind. Based on which timer you are using, corresponding APB1 or APB2 clock and prescaler you need to configure. So for timer 2, you need to configure APB1. This we need to keep in mind. So this is a timer block diagram, general timer block diagram. So which is the clock source for the timer? HSI or system clock at 16 megahertz. It is passed on through the APB prescaler. Output of that is given to APB1, AHB prescaler first. The output of AHB prescaler is connected to APB1 prescaler, right? Then it is connected to another prescaler known as timer prescaler. You can configure it from 1 to 65535. You have already seen the table. This is related to timer prescaler. After passing the clock through all prescalers, it is connected to the timer counter. So last class you have seen that you are having a systematic timer. Whenever it is getting a clock, it will keep on decrementing. In the case of systematic timer, it will decrement. But in the case of timer counter, based on my configuration, you can perform up counting, down counting, or up down counting. Right. For time being, if you are configured it as up counter, what will happen? Whenever it is getting a clock, it will keep on counting up from 0 onwards. Right. And let us take you want to count from 0 to 10. So that you will get a particular delay. So what you will do, whenever it is getting a clock, it will keep on counting 0, 1, 2, 3, etc. It will keep on counting. And how will you stop the timer at a particular value? Let us take, you need to keep on counting from 0 to 10. When it is reaching 10, you need to again reload the value 0. So that it will show that a particular time delay has been generated. How will you do that? That is done by using this timer auto reload register. It is almost the same as reload register in systematic timer. In systematic timer, what will happen? You will keep on counting, down counting, starting from a value stored in reload value register. You are loading a value in reload value register. Systematic timer will keep on counting down from that value. When it is reaching 0, again this reload value will be loaded to the counter, systematic counter. So similarly here what will happen? You can specify the maximum value till the timer counter need to count. That can be specified in auto reload register if you are performing up counting. If you are performing up counting, maximum value of timer counter can be specified here. When you are performing down counting, what will happen? What will happen? From this auto reload register, it will keep on counting down. Right? So the maximum value can be specified in auto reload register in the case of timer counter. So in the case of up counting, say I want to count from 0 to 10. What value you should give here? You need to give a value say 10. So what will happen? Whenever it is getting a clock, it will keep on counting 0, 1, 2, 3, etc. up to the value stored here. When the counter value is equal to this, what will happen? The timer counter will be again resetted to 0. When it is reaching the value stored in auto reload register, it will get resetted to 0. Right? And how will you identify that? When it is getting reset to 0, one flag will be set. What is it known as? Update interrupt flag. Right? In the case of systematic timer also you are having a particular flag. So similar to that, here you are having a flag known as update interrupt flag. So whenever the timer counter is equal to the maximum value or equal to the value stored in auto reload register, whenever timer counter is equal to maximum value in timer auto reload register, it will roll over to 0. When that rolling over is taking place to 0, update interrupt flag will be set. Right. So by keeping track of this flag, you can identify whether the time delay what you have configured is over or not. Right. So, and by using these prescalers, you can configure how much value of the clock should be divided by. Right. Initially, if you are using if you are giving all the prescalars as 1, what will happen? Whatever clock you are giving here will be connected to timer counter. Right. So maximum you can count only from, if it is a 32-bit counter, you can count from 32 zeros to 2 raised to 32. That is 32 ones. 32 zeros to 32 ones. Only that many counting can be possible. But if you are configuring any of the prescalars with any other value, if you are configuring this by 2, what will happen? When you are getting 2 clock pulse here, then only you will be getting 1 clock pulse here. So what does it mean? The total time delay you are multiplying by 2. Right? Similarly, if you are configuring this, so I have told that in APB1 prescaler, you are having only 2. Even though these many values are possible, in timer configuration, only 2 values are possible. That is, APB prescaler can be 1:1 prescaler ratio or 1:2 prescaler ratio. So if you are configuring this also with the 2, what will happen? What will be the total delay taken? It will be multiplied by 2 of AHB prescaler into 2 of APB1 prescaler. So the total delay which is generated by using the counter will be multiplied by a factor of 4, 2 into 2. Again here this prescaler ratio also, if you are configuring it as 2, what will happen? Again the total delay will be multiplied by 2. That means the time delay that can be generated by timer will be multiplied by 2, again into 2, again into 2. Because you have configured these 3 prescalars as 1:2. So this is how the prescaler is working. So if you want to generate delay more than that is possible by the normal timer counter, you can configure the prescalars appropriately. Then the first step for enabling the timer 1 is nothing but you need to enable the clock to the timer. Right. Last class here, what you have done? You have enabled clock to the system tick timer. Right. When you are configuring GPIO, you have enabled clock to the GPIO peripheral. Similarly, here, since I am configuring timer 2, I need to enable clock to the timer 2. How will I do that? Since timer 2 is connected to APB1, in the previous table I have shown timer 2 was connected to APB1. APB1 enabled register you need to configure. So APB1, these many peripherals are there. In that I need to enable only timer 2. So APB1 enabled register is used to enable the clock to the corresponding peripherals. So in my case, I need to enable clock to timer 2. So what should I do? I need to set the 0th bit of APB1 enabled register. How will I do that? I am writing APB1 enable or equal to 1. Right. That means 0th bit of reset clock control register, reset clock configuration or clock control, that is RCC peripheral. In that APB1 enabled register, you are setting it as 1. Reset and clock control peripheral is there. APB1 enable or APB2 enable. All these enables are part of the clock control peripheral. In that first bit I am setting, so timer 2 will be enabled. That is the first step. Right. Similarly, APB2 enable is there. If you are configuring say timer 1 or timer 8 or 9, 10, 11, you need to enable the corresponding bits in APB2 enabled register. Now I am not doing this. I am configuring timer 2. So in APB1 enabled 0th bit I need to set. That is done here. These are some of the registers available for timer configuration. This is timer control register 1, control register 2, status register. Then this is used for capture compare operation. Then this is a timer count register, timer prescaler register, auto reload register. These are also used for capture compare operation. This is known as capture compare register. This is known as capture compare mode register. So these are the registers used for configuring timers. these are the offset addresses. Offset will be starting from the base address of the AHB1. Then next configuration you need to do is you need to configure timer control register 1. So these are the bits present in timer control register. In that only 3 bits you need to configure, right? The 4th bit shows the direction. So for time being, I need to configure the direction as up counter. So I am configuring timer 2 as up counter. So what value should I write? I need to write 0 to bit 4. 0 to bit 4 of timer control register 1. That means you are configuring the timer counter as up counter. Then the 3rd bit, that is known as 1 pulse mode. 1 pulse mode means if you are making this bit as 1, the timer will count only once. Count only once from, that means it will increment from 0 to the auto reload value. Then it will stop. Once it is reaching the auto reload value for the first time, it will stop. That means timer counter will be incrementing or working only for one time. But in my case, I need to make it work continuously. I am going to write say the same LED blinking program. I need to blink an LED in say 1 second. So the timer will count from 0 to a particular maximum value. When it is reaching that maximum value, again it should start counting from 0. So what value I am writing here? I don't need this 1 pulse mode. So I am writing 0. The counter is not stopped at the update event. Update event means when it is reaching the maximum value, it will be rolled over to 0. That is known as update event. Right? So when the update event is occurring, counter should not stop. Again, it should start from 0 onwards. So in order to disable 1 pulse mode in the 3rd bit, you are writing 0. Then bit number 0. This is for enabling the counter itself. Right? So initially counter enable I will be making it as 0. Right? So I will be making 4th bit as 0, 3rd bit as 0, 0th bit as 0. How will I do that? Timer 2 CR1 equal to 0. Right? And once all the configuration of the timer is over, I need to enable the counter. Right? So once all the timer configuration is over, as the last step, you need to make CR1 0th bit as 1. What is 0th bit? Counter enable. So as the last step, you need to make this as 1. So these are the bits present in CR1. Then the status register. Why we are using status register? You need to identify whether the timer has been overflown or whether the update event has taken place or not. Then only you can identify that the particular delay is over. How will I identify that? By checking the 0th bit of status register. What is 0th bit? It is known as update interrupt flag. So whenever the overflow is happening or whenever the update is happening, right? So let us take if I have configured auto reload value as 10. So the counter will count from 0 to 10. Once it is reaching 10, it will be reloaded with 0 or overflown or it will be rolling over to 0. That is known as update event. When that update event is occurring, UIF will be update interrupt flag will be set. Right? So once you have configured the timer auto reload value and you have enabled the timer will keep on incrementing. Right? What should I do then? I need to check, you need to wait until UIF is set. So how am I doing that? While not of timer to SR and 0x01. Why you are giving this and 0x01? I need to mask all the other bits and I need to extract this bit alone. You are ANDing with 001. So all the other bits will be masked 0 except this bit. So if this value is equal to 1, that means counting should be over. Reloading should happen. Or LED blink should happen in our program. But if this value is 0, what does it mean? You need to wait here itself. Counting has not been over till now. Right? So if this timer status register and one exclamation, what does it mean? This is equal to 0. If this is equal to 0, what does it do? You need to wait here itself. Counting is still going on. And if this is not equal to 0, if it is not equal to 0, what does it mean? UIF is set. If UIF is set, you need to perform the LED blinking, and before that you need to clear this flag. So once if this flag is set, you need, as the next step, you need to clear the flag. So for the systematic timer also I told, whenever whatever may be the interrupt flag you are checking for, if it is set, the next step should be clear it. Otherwise what will happen? The next counting process cannot be detected by the program, because it will be 1 always. So you cannot check whether it is 0 or 1, it will be always 1. So once an interrupt flag is set, the next immediate step should be clearing this. How will you clear this? And equal to tilde of 1. I have told that whenever you are giving tilde number, that particular bit will be cleared. Tilde 1 means it is nothing but tilde 0001. That means 0th bit of this will be cleared. Why it is cleared? And equal to tilde of 1. Tilde of 1 means it is complement of 1. Right? What is complement of 1? If it is a 4-bit number, 1 is nothing but 0001. Complement of 1 means 1110. 1110. If you are adding that value with the SR value, it is nothing but 1110. The 0th value bit will be ANDed with the 0. That means the 0th bit will be cleared. So once the update interrupt flag is set, you need to clear it. Then you can write the LED blinking part. So this is the timer counter. Total 32 bits are there. So if you are using a 16-bit timer, only the 16 bits you should use. If you are using 32-bit timer, in our case it is 32. So the whole 32-bit counting will happen. This is a auto reload register. That is also a 32-bit count, 32-bit register. Right? Because always we are checking whether counter value is equal to auto reload value. So both the registers should be of size 32-bit. And this is how the counting is happening. It will start, the counter will start counting from 0000 to a value which is stored in auto reload register. So whenever the timer is getting an input, it will count 0, 1, 2, 3, etc. up to the value stored in auto reload register. In our case, I have stored a value this, that is maximum value FFFF. So it will start counting from 0 till this value is reached. When this value is reached, what will happen? Timer will get overflown or rolled over to 0. At that time, when it is rolling over to 0, update interrupt flag is set. That is, you can see from this timing diagram. Whenever the timer is getting a clock, it will increment 0, 1, 2, etc. up to whatever maximum value you have given, FFFF. After that, it will be rolled over back to 0. So when it is rolling over back to 0, update interrupt flag will be set. Right? Whenever the value of the counter is rolling over to 0, it will be set. So once this is set, you need to clear it manually. That is also you need to keep in mind. Then this is a prescaler, whatever I have told. The prescaler of timer is of size 16-bit. How many combinations you can possible? You can have value of the prescalers from 0 to 65535. So if I am giving a prescaler as 0, what will be the actual prescaler ratio you are setting? It will be nothing but this PSC plus 1. So if you are setting a prescaler PSC value as 0 here, what will be the actual prescaler? PSC plus 1. Whatever clock you are giving as input to the PSC, that will be divided by PSC plus 1. If my PSC is set as 0, I am dividing the input clock by PSC plus 1. That is 0 plus 1, that is 1. So the prescaler counter value can be from 0 to 65535, but the actual prescaler will be 1 added to the PSC. So if I am giving PSC as 0 here, your actual timer prescaler will be 1. Similarly, if I am giving PSC as 65535 here, that means all ones, all 15 bits 1, then your actual prescaler value will be 65536. That is this plus 1. Timer prescaler, that is whatever value you are writing here, plus 1. Right? So if you want to configure a prescaler with 10, you need to give PSC as 9. If I want to have a prescaler as 10, PSC should be 1 subtracted from that. So PSC should be 9. So that is shown here. If I want to configure a prescaler ratio, what should I do? The value will be PSC plus 1. So if I want to configure the prescaler ratio as 1:1, what value should I write here? PSC equal to prescaler ratio minus 1. For time being, my prescaler ratio is 1. So it is 1 minus 1, it is 0. So if I need to have a prescaler ratio 1:1, I need to configure PSC as 0. If I want to have a prescaler ratio 1:2, what should be my prescaler ratio? What should be my PSC value? 2 minus 1, that is 1. 2 minus 1, that is 1. So whatever PSC value you need to configure, the prescaler value will be the one increment, prescaler value will be equal to PSC plus 1. So if PSC is 9, prescaler ratio will be 10. PSC is 10, prescaler ratio configured will be 11, like that. So actually, whatever clock you are giving as the input to the PSC, that will be divided by PSC value what you are configuring here plus 1. So this plus 1 you need to keep in mind. So these are the prescalers option. These are the different prescalers you can configure for timer. Which are they? Ahb prescaler you can configure, APB1 prescaler ratio you can configure, and the timer prescaler which we have seen here. These three prescalers can be configured for timer. Right? So let us take, I am showing a delay calculation for timer 2. What will be the equation showing the delay? We have seen a delay equation for systematic timer. Similarly, this is the delay equation for timer. Now we are using timer 2. Right? So this is a delay equation. These two values you have seen. In the case of systematic timer, it was reload value into time taken for one clock. But in timer 2, your reload value is stored in, or the counter is stored in auto reload register. This into time taken for one clock. So if you are writing this value as 10, if you are writing this value as 10, what will happen? 10 times the counter will increment. So total value will be 10 into time taken for one clock. So 10 into time taken for one clock, that will be your actual delay when you are counting from 0 to n value. In addition to that, these three prescalers also will be multiplied. Ahb prescaler, APB1 prescaler, and timer prescaler. So timer prescaler is nothing but you need to add 1 to it. As I have told that prescaler ratio is nothing but timer prescaler plus 1. So these three prescalers also should be added. Right? So I am substituting P for PSC prescaler, timer prescaler, and N for auto reload value. So if you are taking an example, I need to generate 1 second delay by using timer 2. We are assuming that ASP prescaler is 1, APB1 prescaler is also 1, and my timer prescaler, let it be say 1599. Right? So if you are assuming AHB prescaler 1, APB1 prescaler 1, and timer prescaler as 1599, what value should be loaded into timer 1 auto reload register? How will you calculate that? By rearranging this equation. N is nothing but value that is to be loaded here. N equal to total delay, that is 1 second, into what is the time taken for one clock? 1 by system clock, right? Time taken for one clock is 1 by system clock. So when you are rearranging, what will be n? N equal to delay, that is 1 second, into system clock. What is system clock? 16 megahertz, that is 16 and 6 zeros, divided by Ahb prescaler, that is 1, APB1 prescaler, that is also 1, then the PSC plus 1. What is the PSC now? I have assumed that PSC is 1599. So P plus 1, that is 1599 plus 1. When you are substituting all this value, we will be getting n, or that is the value that is to be loaded into ARR as 10,000. So what does it mean? When you are moving 10,000 to ARR, 1 to prescaler, Ahb prescaler, 1 to APB1 prescaler, and 1599 to timer prescaler, you will be getting a delay of 1 second. Right. So this is how you are calculating the value that is loaded into auto reload register in order to get a delay of 1 second. So this is a program. So what is this program for? You need to blink an LED connected to PA5 with a delay of 1 second using timer 2 peripheral. So what is the first step you need to do? First step is you need to configure PA5 clock to GPIO A. So first step is ASB1 enable equal to 1. What does it mean? You are enabling clock to GPIO peripheral. You are enabling clock to GPIO peripheral. Right? So AHB1 enable, if you are writing 1, that means 0th bit of AHB1, you are setting it as 1, that means you are enabling clock to GPIO A. Next step is you need to configure PA5 as output. How will you configure the direction of a port? By using mode selection registers. So by configuring the mode selection register 2 bits, if you are writing 00 to a particular pin, you will be configuring it as input. If you are writing 01, you will be configuring it as output. 10 alternate functionality will be configured. So if you want to configure PA5, you need to configure bit number 11 and 10. Bit number 11 and 10 is used for configuring PA5. And what value you should write it to bit number 11 and 10? 01. When you are writing 01 to bit number 11 and 10 of mode selection register, you are configuring PA5 as output. That means 11th bit will be cleared, 10th bit will be set. That is why you are writing OR equal to 4. That means 10th bit will be set. In the previous statement, 10th and 11th bit you are clearing. In this step, 10th bit you are setting. So you are configuring PA5 as with output direction in this step. Then from here onwards, you are configuring the timer. What all configuration you need to do? First step is you need to enable clock to the timer. How will I do that? We have already seen APB1 enable register. 0th bit you need to set it as 1. When you are setting 0th bit of APB1 as 1, timer to clock you are enabling. By writing 0th bit of APB1 enable as 1. Then what should be the prescaler PSC value what I have configured in the program? What I have used in the program? 1599. So for time being, I am writing it as, for the general representation, prescaler ratio is nothing but PSC. For prescaler ratio is nothing but PSC plus 1. Right. So what is PSC? Prescaler ratio minus 1. So I am taking the prescaler ratio as 1600. So what will be the PSC value? Prescaler ratio minus 1. Right. So instead of writing 1599 and writing it as a general formula, that is prescaler ratio minus 1. My prescaler ratio is 160. So PSC should be 1600. Then auto reload value also I have calculated it as 10,000. But here you need to keep in mind that in system tick timer also we have seen we are counting from 0 to the maximum value. So So if the auto reload value is 10, you are counting from 0 to 10. So 11 clock cycles will be used. But in my case, what should I do? If I am writing 10,000 directly, 10,001 clock cycles will be taken for counting. But since I am counting from 0, I need to subtract -1 from it. Right? Maximum value in auto reload register -1. Then only you will be counting from 0 to 9999. Otherwise, you will count from 0 to 10,000. So actually, one more cycle will be added. So in order to avoid that, -1 should be given here. Then you are initializing counter value of timer counter to 0. Then after performing all this configuration, you are making control registers 0th bit as 1. What does it mean? You are enabling timer 2. So this enabling of the timer 2 should be done after all the previous configuration, including the configuration of GPIO and timer 2. So now when you are making it as 1, timer has started counting. Then in the while one, what should I do? I need to wait until timer is over. How will I wait? How will I identify that? You need to wait until 0th bit of status register is 1. That is why I am writing while not of timer to SR and 1. You are counting until this value 0th bit of status register is 1. If it is 0, that means counting is going on. You need to wait until 0th bit of status register is 1. What is 0th bit? Update interrupt flag. So when the update interrupt flag of status register is 1, that means your actual delay or counting of one whole counter timer value is over. So when this is 1, what should be the immediate step? You need to clear this interrupt flag. When this is 1, you need to clear the interrupt flag. Then you can perform the toggling or LED blinking. How are you toggling? Output direction register 5th bit. You are performing the XOR operation. XOR means the bit will be toggled. When bit will be toggled? When the time delay is over. So after each 1 second is over, the 5th bit of ODR register will be toggled. Why 5th bit of ODR register is toggled? If you are writing 1 to ODR, corresponding bit will be set. So if 5th bit of ODR is set, PA5 will be set. If 5th bit is cleared, PA5 will be cleared. That is how you are generating an LED blinking program using timer 2 with a delay of 1 second.